So, if I have this one here, these are pretty simple examples, right? Derivative, oh sorry, I should put dash of x. Questions, yeah.
Is that negative f dash of x?
Yeah, negative f dash of x. Okay. So, part one, I'm looking at the derivative of sine of x plus cos of x, okay? What's that going to be? Well, that's really easy. That's just going to be
Cos of x minus sine
cos of x,
minus sine x.
yeah, minus sine of x. Okay, I can just use those standard integrals there. I just want to be careful. Yeah, that's it. I just want to be careful though of any negatives here, right? So I know that when I have sine and cos, when I have sine, if I take the derivative, the sine stays the same. But what happens with cos when I take the derivative?
R goes to the negative.
I've got a negative at the front, don't I? Okay. So if I'm looking at negative sine of x, the derivative of that would be negative cos of
and
x.
then it'll be positive sine.
Yeah, because, right, if I'm taking the derivative of this part, I can take them separately, remember? Because I've got those addition and subtraction operations. If I take it separately, the derivative of negative cos would be positive sine of x. Okay. Cool. Any questions about that? I haven't given you the standard derivative of tan. It is actually in your formula sheet, but we can actually work it ourselves. If I don't know what tan of x is, how can I rewrite it a different way? Yeah, that's actually going to help me a lot. If I write this as sine x on cos of x, okay, how does that actually help me?
No, you know the standard derivative.
Yeah, you can differentiate.
Okay, but what do I have to be careful of when I'm looking at deriving this function?
The negative on the bottom.
Maybe, but what do I actually have here?
Fraction.
Yeah, so anytime you have multiplication of division and you're trying to find derivatives, what do you need to do? Good. Don't just think about, oh, that would just be cos of x on negative sine of x, right? It's not that simple. When you have multiplication or division of functions, you always need to think product or quotient rule. In this case, it is quotient rule. And the form that you usually have is u over v, right? And then what does y dash equal? It equals to u dash minus uv dash over v squared. In this case, what's your u? It's just going to be what's on the top, so sine of x. And v equals to cos of x. Okay. Or u dash v in this case.
Cos of x.
And so v would just equal to negative sine of x.
Yeah.
Let's put this all together now, right? So, when I'm using my quotient rule, I always lay it out like this. I have my u's and v's there. And so when I write it out, I don't make any mistakes.
So,
I can just substitute in. Yeah.
actually, no, don't worry.
You good?
That's alright, yeah. This is the second time you've done that.
Yeah, well, so it's good to ask questions.
So there was like the u equals sin x, and then v equals cos x, but then it changed to the u dash to cos. I didn't know why.
Oh, okay, it's a derivative. Right?
Yeah.
Okay, so I've got the u dash here. What would that be? That's just cos x times cos of x.
Can you put these in brackets?
Yeah, sure. Doesn't really matter though. Minus uv dash, right? Now this is going to, I have to be very careful here, right? Because, and it's actually good to put brackets here, because you're going to have uv dash,
Yeah, that's why.
sine of x times negative sine of x, all over what?
Negative sin x.
What's your v?
Cos of x.
Yeah, so it's cos squared x.
Might be.
Okay. Okay, why is it good to put brackets
That's
here?
why I say, so they don't multiply together.
Yeah, so you got to be careful with these signs here. What's cos of x times cos of x?
No,
Cos x squared.
Cos x all squared. We write that, because it's got one thing multiplied by another, it's going to be itself squared. We write that like this. Yeah, we write it as cos squared x by convention. What's this part going to be there? I've got this whole thing, sine of x times negative sine of x, and I've got a negative at the front.
Negative sine x.
Negative sin x times positive sin x.
Negative sine x.
Negative
So
sine.
It'll be a positive sine
break
squared.
it down first. What's this part? What's this part going to be?
Negative sine x times sine
Negative
x.
sin x squared.
That's going to be
Negative sin
negative.
squared.
But that's gonna.
Yeah, this
cancel
part.
out.
This part is going to be.
Positive.
Sit tight.
Sine
This is
squared.
going to be negative sine squared x. But what happens when we have a negative at the front again?
It's gonna be positive. And the other one's gonna be negative.
So negative times a negative is a.
Positive.
Okay. So this whole thing's actually going to be positive
So it's sine
sine
2x.
squared x. Just like that. Over what?
Cos 2x, and that
Cos
simplifies to-
squared. Don't say cos 2x, that sounds like something different.
And then that simplifies to sine squared x.
Now this is why I got you to do the previous identity before. Look back to your do now sheets. What does cos squared of x plus sine squared of x simplify to? Did anyone get that one? It's actually an identity.
You can't cross it out because they're not multiplied.
Why don't you just try putting your calculator? Put in your calculator cos squared of a number plus sine squared of any other number. And everyone can try different numbers. See what you get. Just put it. See, it doesn't matter what angle you put in, this identity always applies. And everyone would have tried different values, I'm sure.
I did 90.
This just equals to, you tried 90? Or did you try? Yeah, it doesn't matter. It doesn't matter what you put in. It's always going to be 1 on the top. This identity is always going to simplify to 1. You get 1 on cos squared x,
Which is sec.
which is just sec squared x. So remember, what's the original question we're trying to answer? What is the derivative of tan of x? It turns out it's just sec squared of x, right? Sec squared of x. So I can come back to this one. I can fill it in now, right? That's just going to be sec squared of f of x. But remember, we are using the chain rule still here. So what do I need to put at the front?
Yeah, F dash.
F dash.
Yeah.
Just to finish up this part here, we can actually do IV really easily now. I don't have to do that whole thing each time when I'm finding the derivative. I did it, I guess I derived it myself there, right? We used quotient rule to do it, but now we can actually use the standard derivative here. I can actually see that anytime I have tan of f of x, that's just going to be f dash of x sec squared of what's in the function, right? So in this case, I've got x minus tan of x. How can I go about deriving this one?
You can go y equals 1 and minus sec squared f of x.
Yeah, good. Because these are just separate, right? If it's separated by an addition or a subtraction, you can derive them separately. So it would be 1 minus sec squared of x. And because this is just the standard form, you don't have to worry about using the chain. Yeah, easy.